Okay, so this is our review side. This is all cool, yeah? Everyone's good? Alright, so now this is our new stuff over here. So we got a new word, a chord. What is a chord again?
It's like that thing in the circle.
Yes. A segment connecting any. Please highlight or underline any 2 points on a circle. Now, guys, is the diameter a chord?
Yeah.
Yes. Is every chord a diameter? No. What is the biggest chord you can have in a circle? A diameter. Everybody cool? All right, so that's what we got. So let's over here draw a chord. I'm going to draw that chord in black. This is chord AB. Could I also call him chord BA?
Yeah.
Yes, of course I can. That is chord AB. Now, what we just learned was if a radius bisects any chord, you get what? A 90-degree angle. So take our radius and slice it through there. And what does that tell us now about these two pieces? They're the same. And what does it tell us about these two angles? That they're 90. If these are the same, the angles are 90. If the angles are 90, these two are the same. Everybody good?
Yeah.
What if this angle is 91? Would these two be exactly the same?
No.
No. What if this was 5.5 and this was 5.4? Would it be a 90 degree?
No.
No. So could we do Pythagoras? No. Everybody Gouda? Okay, now, over here, before we do any work, I want you guys to look at this diagram and I want you to tell me a couple of things. One, I wish for you to name every radius. Name them. There's 2 in there already. What are they? Remember, you can't give me a distance, you can just name it. O, B, or B-O, like body odor, and O-A. Everybody good? Is O-C a radius? Of course not. Why? Because it doesn't go to the edge of the circle. It starts in the right spot, but doesn't get to the end. Right? Now, what else does this diagram tell us? What other information is given to us by this diagram?
Really confusing.
How do you know that, though? What? Right. So the next thing that the diagram tells us is AC equals BC, doesn't it? Correct? All right. So that is given to us. Is everybody with me? All right. Now, once we know that, once that has been given to us, that tells us a whole bunch of stuff, doesn't it? Does it tell us what X is? What? What is X?
Because X is
90 degrees. Why?
That's not proper.
Because the chord is bisected. So there's the answer. There's the reason. Everybody good? Okay. What is y then? Once I know x is 90, I'm going to draw it on there because I know it to be true. What's y?
Y is
60. Why? Because 90 plus 30 plus 60 gets me my 180. And triangles have to be supplementary, yes? Okay. And finally, what is z? Why? Y is angle OAC equal OBC. Right. Okay. So this is 30. Radii are equal. So it's what kind of triangle? Isosceles. Which means the bottom two angles have to be equal. Is everybody good?
Yeah.
Do you see, and again I stress to you, this is not the set way to do it. Could I have done this in a different order? Of course I could have. The point I'm trying to make is you have to look at how the information you have leads you to something else, which you can then put on the diagram, which then can lead you to something else, which, okay, you got to work back and forth. Does everybody understand? Yeah? Okay, so that was your example. We've talked it through. You guys, let's turn the page over and now let's do the other side. We've used what we know about chords and radii to find angles, but the other side is distances, yes? So to find a distance, I know that Pythagoras is coming to the party. Pythagoras is for distances. If you ever need to know a measurement, you know you need my man Pythagoras. Okay? So, find the length of the chord AB. Well, we know a bit about this chord, don't we? What do we know about chord AB? That 90 means what? That this is halved, yes? So that tells me that BC equals CA, doesn't it? Right? So if I know BC, what would I do to find AB? I just add it or double it, right? So I know that 2 BCs equals AB, yeah? So if I can find BC, do I know how long AB is? So the only thing I got to do is deal with this triangle, yeah? Well, let's take that triangle and bring it out over here where it's bigger and easy to work with. 6, 10, do I know this distance?
No.
No. So that's going to be my L for leg, right? Because I don't want to use A, B, and C. Because Mr. Myers might very well give you a test or question on your final exam where A, B, and C are labeled wrong. So, since we're not going to use A, B, and C anymore, some of you are starting to recognize if you have a hypotenuse, you're subtracting. But some of you still don't get that. So, is there a way to make sure you do it right every time? Yes. Leg 1 squared plus leg 2 squared equals h squared. I am missing a leg, so there's an L squared plus 6 squared equals 10 squared, yes? So L squared plus 36 equals 100, and then you all know how to solve this. Get L by itself. So we minus 36 from both sides, and L squared is 64. What is the last step always?
Root.
Square root. So what is L?
L is
8. So what is CB?
8.
8. We can write it on here. Now we know 2 BCs gets me AB, right? How big is BC?
8.
So 2 times 8 will get me AB, correct? 16 equals AB. Does everybody gets it?
I understand.
Now, again, does this have real life
Yeah.
ramifications? Of course it does. If you have the plans to something, can you use math back at your office to decide how much you need to take to the job?
Yeah.
Of course you can. Can you sit on your front lawn, drinking a pop, and decide how much stuff you got to buy at the store if you're gonna...
Build a house.
I was gonna go with something a little less ambitious, James.
Tree house.
A dog house. Okay.
A goat house?
A goat house, yes.
A big house.
No, you don't build a big house. That's up to the government. Big house, prison, nothing?
Oh, I get it.
All right. So now you guys have to find everything I want to know down here. Go. Remember, if you don't want to use these lines, you don't have to. Okay, so what do we know up here? What numbers do I need? Where does the 5 go? With the A or over here? With the A. So this person that started this work for us is not remembering that, oh, when I have a hypotenuse, I'm going to subtract. He's doing it the old-fashioned way. So that's going to be 169 equals 25 plus A squared. Then what's the next step? Take away 25, so 144 equals A squared. And what's the last step? Square root. So what's A? 12. So A is 12. Now, if A is 12, what does this piece of information tell us about GE? That it's the same. Since OGF is 90, that is a bisected chord, isn't it? Right? Which means A must equal B, so B must also be 12. Is everybody good? Okay, now, the next two questions here have no numbers on it because it's not about the numbers. As I have heard a few times today already, when you guys see these diagrams, you get a little confuzzled. So I have two diagrams here that is only asking you to name the things. No numbers, no math. Just naming. Okay? So I will give you a hint. There are 4 radii in 1A. What are they? First of all, what's common to every radius?
That it's have 2 diameters.
It's 2 diameters, but in this diagram, what is the letter that will start every radius?
Oh.
Why?
Because
it's the center. So we know it's going to be stuff from O. And what are they?
OA.
OC, OD, and OB. Cool?
Yep.
Just practice reading these diagrams right now. Forget about the numbers. And remember, of course, letter order can reverse, right? Could have been A, O, C, O, D, O, and B, O. Phew! Okay, what are the chords? Chords are tricky. What are the chords? Pardon me? D, C, and A, B. Now, what are the diameters? AC and DB. Now, what if I didn't have that there? Could you have put these guys as chords? Yes, because a chord just connects any 2 points in the circle. A diameter is a particularly special chord in that it is the biggest. Does everyone understand? Okay, so let's look at B. That's trickier. What are the radii? Go. Somebody start talking to me. Whoa, one at a time. O-N. O-P. O-Q. O-R. And O-S. Is there one more? No. Why?
Because T doesn't connect with the side.
T is not on the edge of the circle, is it? It's close, but it's not there. What are the chords?
RS.
Whoa, relax there. Slow it down, big stuff. RS. Is there another chord? Is the rest are diameters? And in this question, I specified diameters go down here. What are the diameters? And NS. Can everybody read these things? Okay? What is the key? The letters tell you where to go. If there's 3 letters, then it's, what are you looking at? An angle. Okay? Everybody name for me over in this blank spot, name this red angle and name this blue angle. What is the red angle's name? Angle SOQ. What's the other name he could have? QOS. And what's the final name he could have that is a bad name to give him on this diagram?
QOP.
O. You could call him angle O, but that's a bad name. Why? Because there's an angle O there, 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 there's an angle O there. So angle O is no good. Everybody understand? What's the blue angle's name? QON or NOQ. I'm glad that you're that excited about your math, James.
Sorry.
It makes me so happy. Can everybody read these things? Can everybody read an angle?
Yes.
All right. What? Read what? Chords? Any point, any segment that connects 2 points on the edge of a circle is a chord. So you just go point to point, RS or SR. Okay? Gouda? All right. Move it along, little doggies. There is 6 questions in your notes. Start with them because it's all written out for you, yes?
Yes.
Then go to your textbook and have a look at 397. Start with these 6. Okay? I'm going to... No, just 2A and B. That's all I want to talk about right now. May I speak to 2A and B? Okay. Mark the line segments that have equal lengths. Where are the line segments that are going to be equal on A? MP, because they're to P, has to equal PN, right? And so we know that MN all the way across must be 2 PNs, correct? Why? What information in this drawing makes it okay for me to say this? How do you know it's the halfway point? Because of the 90-degree angle. Once that's in there, we know that's a half. We know PN's 3, 2 times 3 is 6. So how long is A all the way across? 6 centimeters. Everybody understand? Okay. Now, what do we know about B? What do we know is the same? OT and OS are the same. Why, Karina?
Because they're both radians.
They're both radii, right? So OS equals OT, which equals 1.5 centimeters. Since A is OS, A is 1.5. Cool? Awesome. Have people done 3A and B? No? Okay, I'll pause the recording and I'll let you. How big is X? Why?
Because it's equal level.
No. Not quite. Same. Why is X 90? What information here allows me to say that X is 90?
It's a chord directly dissected.
Bisected. Because AC equals CB. So that must mean it's bisected.
Yeah.
So that makes that 90, which automatically means Y is 180 minus
Minus 45.
90 minus 45. So what is Y? 45. Cool in the gang?
Yeah.
Okay. B. What do we know about B? What do we know about this right here? What do I know about that and that? OP equals OQ. Why? Because they're radii. Since those two are the same, that means I have a triangle with two sides that are the same. What do we call that special triangle? Isosceles. Which means, of course, that angle P must equal what angle? Q. Which means X then must be how many degrees? 35. And how big is Y? Everybody cool with that one? Sweet! Now guys, please remember, if you can do one-step ones, if I mash these two diagrams together, is that any different? No, you're just stringing steps together. And finally, your good friend and mine, Pythagoras. So I need BC. I need all of this. But I know that BC is just 2 BDs, don't I?
Yeah.
So if I can find BD, I'm in business, yeah? And I know that BD is 15 and 12 with a 90-degreer. Am I finding a distance? Am I finding a distance? And is that distance in a right angle triangle? So that means we use who? Pythagoras. I have the hypotenuse, so is it plusy or minusy? It's minus. 15 squared minus 12 squared will get me the side I want, which is L squared. What do I got to do to that once I get it? Square root it. So it's 225 minus 144, which is 81, is L squared. What is the last step always? So L is 9. So I know this is 9. But I know I need 2 of them.
So it's 18.
Because this 90-degreer tells me these guys are the same, right? So I need 9 and 9. So BC must be 18. Yeah? Okay. Now, find ON. Where is ON? Is it the red line? No. Is it the blue line? Yes. Is that a radius? No. But that blue line is doing something that helps us, doesn't it? What's it doing? Bisecting. Which means how long is this?
50.
Half of 30, which is 15. Good job. I thought you were confused. Meaning I have this triangle.
It's a right angle.
15, 17, and what's this?
The hypotenuse.
That's a leg. So since I have the hypotenuse, what am I doing? Subtraction. 17 squared minus 15 squared gets me the leg. What do I do to that answer? Square root it all. And it works out to be 289 minus 225 square root, which is 64. So what is L? 8. So how long is ON? 8.